Okay, here we are with another contact. This one's to Angola. Delta 2 Uniform Yankee on 17 meters. 18.098 is the frequency. 0.5 apparently. Yeah, pretty cool. Now we've got that in the log. Got a couple of international contacts, like to Panama. We're using this battery box that I'm in the process of making. Here's my alpha antenna. So it's just some coax running over to it, some impedance matching at the bottom, and as you can see, a grip that you just tighten up, and then it goes up here into the sky and sends radio waves. Very similar to how our drones work, but much longer frequencies. As you can see, we can make an antenna tiny for these 5 gigahertz frequencies, and then a little bit longer for these 900 megahertz frequencies, and a little bit smaller for 2.4. And the frequency that is currently using is called 17 meters, meaning the frequency itself, the length of the frequency, is approximately 17 meters long, or 18 million cycles per second. And if you were to stretch one cycle in 1 second from here out 18 meters, that would be the full length. So why don't we use an antenna that's 18 meters long? Because if we did, full cycle of a frequency is a sine wave. And what is a sine wave? It means it starts at 0, goes to positive voltage, and then goes back to 0, goes to negative voltage, and then goes back to 0. So if you put positive and negative voltage on a wire at the same time, and they're both equal distances apart or close to it, that is how a noise canceling headphone works, because it's injecting the opposite frequency of what your ears should hear, and it zeroes it out. So that's why our antennas are not the full length of the frequency. Some like half wave or 5/8 wave, there's some fraction of the full length. So let's get this 10-inch drone up in the air. Enough with the ham radio. So you can see I'm going to be flying with my 6S 21700 battery packs that I made the other day. Make sure that we're not going to eat up any of our balance leads, and then we can plug this in so the GPS can start sucking up some things. And as you see, it's got right hand polarized. It says RHCP, and then this one is a RHCP. But I'm going to be using my Goggles 3 from DJI. Can you use Goggles 3 from DJI with right hand circularly polarized antennas? I say you can. So let's see. We're going to use the GX12 Radio Master. We'll turn this on, and then that'll make that quit beeping over there. So if you leave it plugged in too long, it goes into Wi-Fi mode. And I have a feeling that's what happened, because there, it connected. It's random video time. Okay. So, I hate it when I clear my throat. So sorry about that. I could edit it out, but I'm not going to. Okay, so this is going to be basically just the whole test of seeing what the transmission is like using 2 right-hand circularly polarized antennas on the DJI O4 Air Unit Pro, and receiving with the Goggles 3. And we're just going to go at this. I've actually lost an HD0 drone right around here. So if you fly too low, there's a berm between where I'm standing and that area. So you have to keep a little bit of height, or you can just quickly lose full control of your drone and video, and off it goes. So anyway, so what we're doing here
using
is
2
just seeing how
right-hand
far we can go
RHCP
without
antennas.
the megabits per second dropping. And you can see it's staying at 60 the whole time, which is pretty good, especially because everywhere you go, if you search, if you chat GPT, I would guess that generally speaking, it's going to tell you to use left-hand circularly polarized antennas. But what if all you have is right hand? I mean, I have both, but I wanted to try it with right hand.
So this has a right hand, and um, one is just straight along the frame and sticking up the back. The other is uh, drilled into the top plate and basically sticking straight up. Gets it above the battery, and then the one sticking straight out the back. Now, right here, check that out, man. That is not sped up. That is just a 10-inch with not even full throttle. This dude moves, man. It really does move quite a bit. So, but you can see 60 megabits per second. I used to fly over here with a Caddx Vista on my goggles too, and it would really drop. You can see there's a little bit, but man, the goggles 3 and the O4 air unit just really know how to lock in. And at this point, I'm starting to get behind another berm. So again, this is pretty far away. Uh, we're over half a kilometer away. I believe it's still in meters there. Yeah, that's 700. So we're 3/4 of a kilometer away. And in DJI speak, that's not very far, but you've got to understand that it's not a clear line of sight here. And you can see I'm getting down to 8, 10. When you see the red, it's time to get some elevation, pull up, and start getting your signal back. And so that's what we're doing here. And using lithium ion, so the voltage is not going to go down that fast. They're 21700 Moly cells, and there's two of them. So two, let's see, there's this is 9,000 milliamp hours, so 9 amp hours of lithium ion power, and you can just continue flying for quite a while. And here we go. Just keeps going, going up. Generally not going to have a problem. Now, if I were to keep continuing past the lip where I lose line of sight, then it would almost be like snapping a chalk line across where you can get access to the signal. And the signal, once it crosses that line, I mean, look at this. This is all just rock right here. The rock is gonna just immediately kill the signal. Now, the cool thing about mixing some ham radio with this is you learn things about radio propagation and something called knife edge effect. And so there is a possibility you could go quite a bit further because you do have that 90-degree kind of edge there. RF is not an exact straight line, and so you are going to get some additional propagation characteristics by the type of terrain that you fly over. And uh, I've seen that myself where I've bounced signals off of Pikes Peak or other mountains to be able to get to somewhere that there's no direct line of sight there. And that's just part of the reflectivity of rocks. When I was in uh, the Virgin Islands, I set up a vertical antenna on a sailboat and was talking to people literally all over the world. Saltwater it's about the most excellent reflector of RF that you can get. Uh, so while it is uh, dangerous to fly over water, when you see people out at the ocean flying, as far as the RF is concerned, you're going to be able to get a long ways, but one of the bad parts about that is everyone else is too. So if you're um, near where there's a lot of houses with Wi-Fi, all of that's going to end up going over there as well. And I don't know what I was doing there. Oh, I know. A friend of mine wanted to see me trippy spin with my 10-inch, and so I was trying to get the hang of it up in the air. and that's not really a good idea. So, um, I'll show you how bad of an idea it is here in a second, because there's one spot that I would like to trippy over here, but it's too dangerous. It's too close to the power lines, and it's just a telephone pole that goes up in the air. And there it is right there. I ended up hitting the ground, breaking a prop, so you don't get to see it all. So here it is doing a return to home.
But I do a full return to home here. I wanted to see what it's like to go all the way down, see where it lands based off of GPS and where I took off. And I think it had 12 satellites, and then it comes down. And the other thing that's interesting to know is when it lands, it shuts itself off. I'm not sure how it knows to do that, but it does.